Today, we're going to dive deeper into the shell. We're going to look at some more basic elements like navigation and files and some miscellaneous things. And after that, we'll look at power tools or programs in the shell that make it really powerful. And then daisy chaining, which is chaining the output of one program into the input of another. First off, navigation, files, and miscellaneous. Get your cheat sheet out. Hopefully you printed it out. If not, it can go on your screen too, no problem. Remember, in the context of file paths, tilde is home, or /home /username, whatever your username might be. Remember that most paths that we use are relative paths. They're relative to your current working directory. And at least in the file navigation scenario, what we're doing is analogous to what a file browser would do by going into folders and looking at files, going to parent folders, and so on. And tab. Like I said, I can't emphasize this enough. This will save you a lot of typing and heartache when it comes to adjusting to the shell. A concept that we've touched on is root. So it's the highest directory, or just /, but it's also the Linux super user. So this user has all privileges and can do a lot more than a normal user. So I'm going to go to webshell.picoctf.org, which will work fine if you have an account here. If you don't, you will have to create an account at picoctf first. I'm in. So the first thing I do in any situation is ls-al. And this is, of course, the file listing in the folder that I'm in. If I wasn't home already, I could type cd, enter, and I would be home. But I'm there already, so it doesn't really do anything. All right, so I'm going to navigate to a folder. cd, n, tab. That worked really nicely. ls-al again. Oops. There's a space there. All right, so here's the contents of this navigation-demo directory. And I'll explain this listing in more detail now. So this first column, as you've probably gathered, is the file name. This next column is the last modified timestamp. The next column is the size of the file or folder. The next one is the group name that owns the file. Next over is the username that owns the file. And of course, these are the same. That's because in Linux, when you create a new user, a group of the same exact name is also created. So that's just the default for files that this user owns. This next column, it still has a little bit of mystery to me, but it's basically the type, and 1 means file, 3 means directory, and I think 2 means directory too, but we'll have to research that more. And this last column is the permissions. We'll delve into that more later. All right, so to go further down into the directory, type cd f tab. It doesn't do anything. Well, if I look at the listing, there's 2 directories that start with F. so that's probably why. If I hit tab again, it will list all the matching directories up until that point. So I'm going to go D, so it completes after that. So this is what an empty directory looks like when you use -al. And I should explain -al a little bit more. So -a means all, so it doesn't hide anything. You can hide files in Linux by just putting a period at the beginning of the name. And -l means the longer listing, which is why we get all the info up here of timestamp and size and user ownership and permissions. If you do ls without the -al in an empty directory, it doesn't output anything, which I think could be kind of confusing, but it's okay once you get used to it. All right, so to go to my parent directory, I do cd ... Go to the other folder, I type out fo, ls-al. Here's the contents of this folder. Let's try looking at this file with cat. So it's running into some ambiguity. It doesn't know if it's second file.txt or second folder. So I'm going to just type I and then tab again, and that's going to give me the file. Its contents are file2. Do cds tab. CD is smart. It knows that there might be two items with the same prefix in this folder, but only one of them is a folder, so it auto completes to the right thing. Okay, so here's some interesting stuff. Files.zip and monster.txt. Cat M tab. That's almost too much for my terminal window size, but it is a little bit shorter. So to get rid of that from my screen, I can do the clear command. Then I'm given a fresh terminal screen. Now this is probably not something you should do, but it's not like it hurts anything, but you'll see why. See, files.zip is what is called a binary file, so it doesn't really go into the terminal very well. It seems to be done. It is. So sometimes that can break your terminal when you do that. And if that happens, you can do reset. That's a harder reset than clear. So just be careful about catting binary files. Usually anything .txt is good. Sometimes files don't have an extension at all in Linux, especially. But definitely avoid catting zip files because those are always binary. So I'm going to go home. So this takes me back to home or tilde. To get back to that folder, instead of doing it step by step like I did the first time, I can just do that, and I'm back with the monster file and the zip file. Another way of going back to home, which this is always going to be different depending on how deep you are into the home directory, is using the multiple parent shortcuts. That takes me back to home as well. See, my home is /home/serial-picoctf. I can go to root by doing that. And here's the file listing. This is a lot of system files here, so it's okay if a lot of it seems obscure or obtuse. If I go to home, go to serial, you can see that file path changes into tilde, hopefully proving that /home/serial-picoctf is equivalent to tilde for this user. Go back to root, list it again. Let's try root. That looks exciting. Okay, permission denied. So that's a sensitive directory that I'm not allowed in as this user. So hopefully you're more comfortable now navigating around in the shell. These are the commands that we used, mostly ls and cd, but we did experiment with pwd and cat. And I think what these are short for is ls is list, cd is change directory, pwd is print working directory, and cat is short for catenate, or catenate to the terminal the files of this, or the contents of this file. So of course there's still relative and absolute paths. We mostly worked with relative paths, but I'll point out significant relative and absolute paths as we run across them. We saw that you can take it slow and go step by step, or you can just do it all in one command, sort of jumping to the end. So now let's delve into some file manipulation in the shell. Let's go back to that navigation demo folder. Let's copy file 1 to a file called file 3. This is just showing the contents of these files. And they're the same because file 3 is a copy of file 1. Now let's change them a bit. Let's use Nano, the text editor, to edit file 1. All these keys at the bottom of the screen, all the ones with caret, that means control. So usually what I do to save a file that I'm exiting is I control X to exit, save modified buffer Y for yes, and then the file name to write, just the same file name is fine. So just hit enter, it'll overwrite it. See, now file 1 says this, what we change it to. I'll do the same for file 3. Control X, Y, enter. There's a trick I can do. If I do file star, it'll cat all files that start with this prefix. So we see file 1, file 2, and file 3. We didn't modify file 2, and it was also copied from file 1. So RM is remove, it deletes stuff. Make dir creates a directory. There's another directory. Let me try to remove it with RM. It throws an error message saying cannot remove another directory. It's a directory, which is just a limitation of RM. You can do it though if you do RM-R for recursive. Another directory is gone now. I'll show you another way to delete directories. You can use rmdir. That doesn't require any options to be given to it to be able to remove directories. Another handy file command is mv or move. Move file 1 to my file. You'll see that file 1 is now gone, replaced by my file. And it has the same contents as file 1. The last file command I want to highlight is the touch command. Sometimes it's handy to be able to just create an empty file, something to start with. You can see there's nothing in it. So we saw CP or copy, Nano, which is a text editor, RM, which deletes files, makedir, which makes directories, rmdir, which removes directories, move, which can rename a file, and touch, which can create empty files. I also kind of tease this asterisk shortcut for making it possible to reference multiple files at the same time with catting file 1, 2, and 3 all at the same time. That's another magic thing that can come in very much in handy. So now for some miscellaneous commands that are really helpful. Man is very helpful. It's short for manual page, and it suggests reading the manual page for itself here. All right, so this interface is a little different than the command line. With this, you can go up and down with arrow keys. You also go side to side with the arrow keys. Space goes a full page ahead. Lowercase g goes to the beginning, and uppercase G goes to the very end. After going to the very end, we can now see how long this manual page is, and the answer is it is 502 lines long. So you might want to search in such a massive file. So to search, do /. You can search for like an option, and then use N for the next hit, or capital N for the previous hit. Here's the description of the option. And you can use Q to quit and go back to the command line. You can also give it a section reference to avoid going to the wrong entry file. So one is commands, built-ins, and programs. Printf exists in multiple sections. Exists in one. Printf format and print data. It's a program you can use on the command line. And it also exists in the C manual, which is a family of print statements. Echo can be really useful as well. You probably remember me using it. It does nothing if you don't give it any arguments. If you echo tilde, it displays your home directory. It's really useful for echoing out shell variables as well. And of course, just a standard wget can be really helpful as well, and I go through its usage and some hints and problems that I've written. So you need a URL with wget. We can look at its help for more information. So it seems like we're only seeing the very end of its help information. So one thing you can do is type this pipe operator. It's the shift option for backslash on most keyboards. And then type less, which is a program that turns output into pages so it's more easily looked at. And this interface is just like man. So up and down, arrow keys, left and right, space for a whole page, lowercase g to go to the beginning, big G to go to the end, and / to search. So let's go to a web page that's pretty simple. Yeah, so it's a big page of text at first. So that'll be a good example for wget. Wget, same URL. All right, so it saved it as index.html.1. So it's a lot of code. We haven't gotten into web programming yet, but we will. But here you can see that wall of text that he has. Just to prove to you that wget is getting the same document that we did in the browser. So I'm going to use an absolute path. When you use tilde, it becomes an absolute path because this actually, as we saw with echo, starts at root. We wouldn't have to, though. Since we're already at tilde, we could just use a relative path of navigation, folder, second folder. See what unzip does. Default action is to extract files in list. So unzip file. It may or may not contain the .zip suffix. So let's list our folder. So yeah, we just extracted an archive from the files.zip file. Now I have this files folder. And this just has a bunch of downloads from Project Gutenberg in it. It's part of a different challenge. Okay, so we're going to explain permissions a bit more now. Permissions come in 3 flavors: read, write, and execute. And these are shortened in the command line to R, W, and X. This is a line taken from the command line. As I pointed out before, this first one is a user. Second one is a group. And these R's and W's are permissions. So now we're going to focus in on the permissions exclusively. So this first group of three are the permissions for the user that owns that file. Next are the permissions for the group that owns that file. And finally, it's the permissions for everybody else. This is an example if everyone was given every permission on a file. This example is if everyone was excluded from all permissions on the file. And actually, even with a file with no permissions given to anyone, root can still access and read it and write it. So that brings us to the chmod command. So it looks like chmod, we can specify some optional options. We give a mode, and then we give a file. Mode is of the form hieroglyphics here. So this is what's called a regular expression, but we're not going to get into that right now. Let's see if the man page is any less obtuse. Well, this does have a lot more information. It seems like it's a little bit more introductory. You can also use page up and page down in this interface. It's actually a really short man page. So I'm going to create a shell script that just does an echo. This is what's called the shebang. Don't worry too much about it. It just tells the system what interpreter to use to run the script. Enter. Okay, now I want to run the command. To run scripts, you have to do // I'm going to try typing sc, see if it autocompletes. It doesn't, which is a warning sign. We can kind of force it. It says permission denied, which is really weird because I just created this file. What's happening here, and this happens to everyone, is that the executable permission isn't given to anyone. So to grant that permission, you have to use chmod. Do +x, which means add the executable permission. Also in the command line, you can just do up arrow, and it will go through your history of commands. And it works now. Next miscellaneous command, this could easily be a power tool as well. I just put it in here because of just the need for it every once in a while. When you run it, it goes right into a Python interpreter, but I'm not going to use that. So Control D to get out of that. Instead, I'm going to write a script. Script.py. This is going to do the same thing as the previous shell script, just with Python. Control X, yes, enter. Now, maybe that seems strange that works when we didn't add the executable bit. But the reason it works is because we're executing it through Python 3, so it kind of sidesteps that issue. Finally, the last miscellaneous command that can be pretty practical is exit when you're done with the command line. So we saw man, which is the manual pages of Linux, can help out with a lot of different commands and programs, how to use them and how to get the most out of them. Echo, which is a simple little command that just echoes to the terminal anything that you type in, but it can also interpret shell variables and tilde. wget, which just gets a URL into a file on your computer. Unzip, which can take a zip archive and decompress it into your file system. Chmod, which can add the executable permission to scripts that you want to run. Actually, running scripts, which you use // for that. And Python 3, which can run Python files without adding the executable bit. And exit, which can just be used to exit your terminal and pick it up later. So here's the first problem set. Nice netcat, which would be somewhat of a review. Tab attack, Python wrangling, and Magikarp ground mission. Good luck. Now we're going to talk about the power tools of the shell. The first one we've seen already. It's called less, and I don't know if I would call it like really powerful, but it's really helpful. It can take any input and divide it up into pages that can be easily scrolled. Let's see it in action. I'll use an absolute path to go to the navigation demo. So here we are, just like we left it. Let's look at less. If you just try and invoke it without any arguments, it says missing file name, do less -- help for help. Well, let's see what that has to say for itself. So it brings us into an interface like man with up and down arrows, space, / to search, all of that. And it looks like a lot of keys. It's like a key map. I'm going to hit Q and exit. I'm going to try the man page, see if that's any more helpful. Here's the invocation of less. And when there's square brackets around something, it means that it's optional. But sometimes you have to include something if you invoke it in a certain way. So file name is the last option that we can include. So let's less this file. So this is Frankenstein by Mary Shelley. And again, this interface is just like man, up and down arrows, navigate, go side to side as well. Space advances a whole page. Page up and down keys work as well. You can search with /. If I read too much, I'll get engrossed and forget what I'm doing. I love this book. So yeah. So that's really helpful, using it for files that are really big. What I use it more for is if I go to this directory, try to ls.al, there's a lot I'm not seeing. I'm only catching the tail end of that file listing. So neat trick, if you press the up arrow, you'll go back to your last command. You could add something to it, the pipe less. And remember, pipe is the shift character for / on most keyboards, just a vertical line. Sometimes there's a space in the middle of the vertical line, but most of the time it's just solid. So if I pipe this into less, now I can see the very top and everything in between. Next command is history. It remembers all of your bash commands that you enter, and you can re-invoke any command with the right number. See, I have 950 commands in my history, and the very last one is history. But if I want to invoke a previous command, I can use the up arrow like that. But if it's too far up there, that might be inconvenient. So I could do ! 931, which is just an ls command. See, it does ls again. Your previous session history is stored in this file in your home directory. Which is good to know. I've used it for a challenge in the past. Next, fan favorite, grep. This is a command that has a lot of options and has a lot of power, and can take a while to grasp all of its possibilities. All right, so we're going to go deeper into our home directory. And let's see what grep does with no arguments. Cool, it gives us a really brief rundown of how to use it. Grep, option, patterns, file. If we want more information, we can do grep -- help. And that is just the tail end of the output, so I can go up and pipe it through less. Here it gives us an example, which is pretty helpful. Unfortunately, not every command gives examples, but grep does, so that's nice. Might want to know what -I means. So we don't even have to search, it's just right here. It means ignore case. Let's look at the monster file. So this is a file that contains all the lines in Frankenstein that have the word monster, plus a little bonus line. So we want to see if grep can find this line, get rid of all the chaff, get right to the wheat. And indeed it can. But what if we weren't sure of the capitalization of Pico CTF? Because that actually is a question that comes up sometimes. Like a lot of people think the P is capitalized. That breaks it. Well, we can use that handy I command, or I option, to make it case insensitive. And then we still find it. What if we didn't know what file the flag was in? Pico CTF fake being the flag. We could just use star to look at all the files in this directory. So it says, is a directory as an error, which means it didn't actually go in there. And it says that files.zip matches, even though it's binary, it found it. And for monster.txt, it actually found the exact string and prints it. What if we weren't even sure what folder it was in? Well, now it gets stopped because second folder is a directory and it doesn't go in there. But we can actually add an option R for recursive. Then it finds it. And it finds another one actually in what we unzipped. But that's the monster one. If we wanted to, we could look up the manual page for grep and search for -R. There's some false positives to go through with the N key. So here we go. Recursive. Read all files under each directory recursively. Actually, when you're using the R option, you don't even need the star to say all files because it does that automatically. Since we know that this file is just every single line in Frankenstein with the word monster, we could do something called an inverse search with grep, which is -v. So let's look at every line that doesn't have monster. That gets the flag as well. There are a lot of options with grep, and some commands and programs I don't ever use the options, but grep is one that I definitely use the options pretty frequently. So it's good to practice with it, with different challenges, with different tutorials online. Just get your feet wet and just practice with it. Next one is find, which might sound like what grep is doing, and it is, but find acts more exclusively on files than it does the contents of the files. And find actually does a lot of work without any arguments. What it's doing is printing the name of every single file that's in this directory or under it. And find is actually a little bit less helpful with help. Help works, so that's nice. And it fits in my terminal screen, so I don't have to use less. So find, path, expression. And find can get really complex, but we're going to just demonstrate the more straightforward usages of it. Let's go back to user bin. I'm going to demonstrate finding all the Python files in this directory. So find, then dot is the current directory. Name is the file name, so the file name must be Python. So it finds one match. Now I'm going to work on broadening this search so that it catches more potentials. First thing I'm going to do is add a star to the end of Python. That way it matches any file that just starts with Python. That gets a lot more matches. Finding Python 3, Python 3 config, Python 3.10. Now I'm going to add a star to the back of Python as well. So I found a lot more. IPython 3, IPython, DH Python 3, Sage Python. And actually, the current directory is the default for find, so we don't need to specify that here. So that gets the same results. And we could also use a absolute directory with this. That might be handy because it actually prepends it to the end of the file names, so that could be more usable in certain applications. The next one is file. File is really cool. It can tell the type of any kind of file, and it does so by looking at the magic bytes, which are the first few bytes in a file header. And it helps Linux treat files like they need to be treated. Whereas on Windows, it goes off the file extension, which can be easily spoofed and not as reliable as the magic bytes. So I'm going to go back to the folder with the zip file. Here's its brief help message. Really what to take away from this is file and then the name of the file. All this other stuff is optional. And honestly, I don't really use many options with file. I just use it pretty vanilla. See, monster.txt is Unicode text with CRLF line terminators, which means it was probably created in Windows. Oh. That's a zip archive, which the extension matches, but we could move it. Without an extension. And file still knows it's a zip archive. Didn't really trip it up at all. Next command is strings. Strings is like a filter that filters out all kinds of binary information and instead only gives you the ASCII or the plain text information, which can be really useful when searching through binary files. What happens when I do strings? Well, that doesn't seem very helpful. It just kind of ends, or it seems to. What if I type something? Oh, it kind of echoes it. Oh, did it stop working? Oh, it's still working. Do Control-C to get out of this. So let's try and find a reason why that behaved like that. So here's its help text. The thing we were running into is that it only displays strings that are at least 4 bytes long. So when I was less than 4 letters, it didn't echo the result. And you can use it just on the command line like that. I'm not sure how that would be very useful. But the more common way to use it is to do strings and then have a file afterwards. So I could do strings. We already know that files, now something, is binary data. What happens when we strings that? Okay, so maybe that's a little confusing what happened, but it's just grabbing all the strings 4 length or greater out of the file and ignoring all the binary data. Maybe I could give that to grep and have it look for Pico. So that happens like instantly. What's sort of interesting is what happens when you just grep for Pico in the file, it does this binary file matches, which is sort of helpful, but much more helpful is strings something first and then pipe it into grep. And apt, we saw this in our first lecture. I demonstrated how installing GIMP is a lot faster in the command line than through graphical means. I'm not going to demonstrate apt right now because it doesn't work with the web shell. And yeah, that's the main reason. If you get your own Linux computer, like a virtual machine on your Windows or Mac host, apt would be fun to play around with. Just examine it like we've been examining all these other programs, run the command without any arguments, then try -h, then try -- help, then try the man page in whatever order. And sudo, we also talked about in the first lecture. I'm not going to demonstrate it here because sudo doesn't exist in the web shell, but it stands for super user do. And I will demo it on my computer. So another command is who am I, and that correctly reports that I'm Cyril. Now if I use sudo who am I, it says root because I'm doing an action as root when I use sudo. So that's a very powerful command. All right, so the second problem set in the Pico gem is first grep, first find, and big zip. Good luck. This last part is called daisy chaining. It's a powerful way to use programs. Let's consider this abstraction of a program as a black box. Now, not too long from now, we'll actually look into these black boxes and see what they do and how they work. Because really a program isn't a black box. It's more like a schematic that someone gives to you that has the button on it that can run it and use it. But for now, let's think of programs as black boxes. And by that I mean there's input and there's output, but we don't really know what happens in between. With the programs that we have been using, their output goes to the terminal window. One example of this is echo hello. Hello is the input to echo, and it's also the output. And it goes to the terminal window. Another example would be the program file that does a little bit more than echo. Mine.txt is the input to file, and its output is ASCII text, which is the file type of the file. And this is printed to the terminal window. Now, sometimes we'll call the terminal standard out or standard error. These are technical terms for programming. But with some advanced shell invocations, we can really use programs as puzzle pieces and kind of fit them together so that they help each other out. The first method of special invocation is file redirection. You can save the output of a command to a file. You do that with the greater than symbol. And this is an example of what that would look like. So if you do file mine.txt greater than output, then now output's going to contain that ASCII data line. So in a file is the input to echo. Echo outputs that. Instead of to the terminal window, it outputs it to the new file.txt. Now when you cat this new file, you'll find that in a file is what it says. You can also do the file redirection backwards. You can say instead of greater than symbol, a less than symbol, and you can make the contents of this file be the input to this program, in which case cat would still say in a file to standard out or the terminal window. So this is good for saving any results you might want later and debugging steps in complicated shell invocations. So now daisy chaining. All this is connecting the output of one program to the input of another. And you can craft these multiple step functions that take place in just one command. And you do that with pipe. We've seen this already with piping to less and piping to grep. So here's an example that we've already done in the shell. We do ls-al and we pipe it to less. So what's happening is ls is given the input -al and it produces a file listing. And this file listing goes to less and becomes a paginated listing. So you can scroll easily through it on the terminal. Slightly more complicated command is this: strings bin pipe to grep, grep for pico, pipe to less. So the first step finds all the strings in bin, and then grep searches for any matches with pico. And then all those matches are paginated and sent to the terminal window. So, armed with that knowledge, here's the last problem set for this lecture. Static ain't always noise, strings it, and plumbing. Good luck.